Hey guys, so in this video we're going to be covering IXL sections R4 and R5, evaluating logarithms. Both of these sections cover the same concept, so after watching this video you should be closer to doing the problems in both sections. Let's go ahead and read the paragraph. So when calculating logarithms, remember that logarithms are a way of thinking of exponentials backwards. Thus, you should ask yourself, what power does the base of my logarithm need to become the number that I'm taking the logarithm of? The answer to that question will be the number that your logarithm evaluates to. As well, your calculator has keys for both common logs, log, that have a base of blank, and natural logs, ln, that have a base of blank. So these are two things that you should have memorized by now. Common logs are going to have a base of 10, right? We have a base 10 counting system. Our common log is base 10. And natural logs are going to have our natural base, or our natural number of e in our base. Okay, and we can see this stated below right here. That's our common log, this is our natural log, and this is what e approximates to. Alright, let's go ahead and start looking at some of the problems. Before we do so, remember our steps are we need to think of the blank needed to make the base equal to what the log is being taken of. So remember, we are looking for the power that the base needs to become what the log is being taken of. And then as well, we can also use a calculator to evaluate typical logs, such as blank with a base of 10 or blank with a base of e. So remember, this is the common log with a base of 10, or just log. And this is the natural log, ln, with a base of e. Okay, let's go ahead and look at this. So our first question, remember we're trying to get the base to what the logarithm is being taken of. Right, and we're trying to do that with an exponent. So the question you should ask yourself is 5 is going to need what exponent in order to get to 5? And the answer to that question, maybe you need to think about it, is going to be 1. Right? This will complete the expression, and so therefore this logarithm calculates to 1. Okay, right, we looked at the base, found out what exponent needed to get to what we're taking the logarithm of. Okay, number 2. Alright, another log to evaluate. Notice there is no base written on it, and it just says log. You need to remember what the base of that is going to be. So this is the same as log base 10 of 1000. Okay, remember, if we don't say what the base is, we assume it to be 10. So now that same question is, how do we get 10 with some kind of power to become 1000? Okay, so maybe you need to pause, think about it. How many 10s need to multiply to get to 1000? Well, you need 3 10s. Okay? Alright, the next one, evaluate the log. We need to evaluate this. So again, we have just a plain log of 1 over 1000. So the question again is, what exponent do we need for the base to get to what the logarithm is being taken of? Notice again, it doesn't say what the base is, so we have to assume it to be 10. This is our common logarithm. So 10 to what power will get us to 1 over 1000? Okay, and remember in the previous problem, we brought 10 to 1000 with a power of 3. However, now we have a slight twist here. Instead of being on the top or in the numerator, our 1000 is underneath in the denominator. AKA, we had to flip this in order to create this fraction. So remember, when it comes to exponents, if we're flipping something, we're going to use a negative sign to do so. So the answer to this will actually be negative 3. Okay, and you should also be able to enter this into your calculator. Remember, your calculator will have the log button. Just type log of 1 over 1000, and you should see negative 3. Alright, number 4, now we have a logarithm that is not going to be so nice to calculate. So we are going to have a log base 10 right here. We're taking it of 72. So the question again is, 10 needs what power to get to 72? Okay, and think about that for a while, but eventually you're going to realize that there's no nice number that's going to make that work. right? There's no even number that's going to make 10 raised to a power equal 72. So what we can do is, so first off, if we want an exact number, we'll need our calculator. Second off, what we can do if we don't have a calculator is we can approximate what this thing will be. How we approximate it is by creating a upper boundary. Right, so we're going to create a upper boundary, and we're going to create a lower boundary. Okay, so let's go ahead and create these two things. What we can do is, let's get rid of this. Alright, so right here, we're going to think of log of 72. And what we're going to do, 72, not 70. And what we're going to do is we're going to think, well, oh my gosh, I did it again. What's going on? There we go. Alright, so we have the log of 72, and so we're going to ask ourselves, what is a even log that's just above 72? Or, right, what is another log with a base of 10 that could have an even calculation that is higher than 72? So 10 to what power could equal another number higher than this? Well, 10 to the power of 2 could actually equal 100. Right, we see 100 would be the next number above 72 that's been exponentiated with 10. So we know the answer to this one. Well, 10 needs a power of 2 to get to 100, so this could be 2. And this could be our upper limit. Now we can go ahead and also define a lower limit for it. Right, so again, we'll make another log with the base of 10. And now we can look for another number that can be gotten to with exponentiation of 10 that is going to be lower than 72. So what could that number be? Well, 10 would actually work really well because 10 raised to the power of 1 would equal 10, meaning this logarithm actually equals 1. So now you see that we've just created two boundaries where the highest is 2 and the lowest is 1. This means this logarithm has to fall somewhere in between. It has to be 1 point something. And this can help you narrow down your answers. Now, I would approximate, because it's 72 and it's a little bit closer to 100, I'd approximate maybe 1.8. That's just kind of a guess, but it might not be too bad. What we would really need to do is get out a calculator and calculate it. So I'll go get my calculator and type in log of 72. Okay, so I have my calculator, and now I type in log, and I should be able to find the button on there. It should be a button that just says log. Any scientific calculator will have it. So log and then 72. And I calculate, well, lo and behold, that actually wasn't a bad guess. I actually get out 1.85 and then 7. So right just between 2 and 1, I was able to predict where this was going to fall. So this is our answer. Remember, we rounded to the nearest thousandth. This would be the tens, the hundredths, and the thousandths. So we look to the 7, see if it needs rounding. It's not going to round up, so it stays the same. So we get 1.857. I guess let me go ahead and write out that full decimal. The 3 would be right there. That's what determined whether the 7 got rounded. Okay, next one. So we're going to look at this, and we can type this into our calculator, but you should try and solve this mentally by asking the question that we've been asking for our previous logarithms. So that is, the base of this needs what exponent to equal this? Or in other words, the base of ln, e, needs what power to equal all that stuff, or e squared. And when you think about it like this, it's actually pretty straightforward what needs to be in the blank, right? Obviously, it needs to be a 2. Visually, that makes sense, and just, well, e squared needs to equal e squared. That just makes sense. So this logarithm will equal 2, and we're actually going to see that whenever we take a log of, or we have a log with a base equal to the base of what's being taken of, that we just get the exponent coming out of it. That's a property we can learn about later, but for right now, that one is 2. Okay, same deal. So we have 9 ln 9 ln of e. So remember ln, we're going to first calculate the logarithm, going by order of operations. Ln has a base of e, so we're going to need to raise e to some power in order to get to this e right there, right? What it's being taken of. So again, not too hard. We're going to see that that power is 1. So ln of e just calculates to 1. And then our 9 can come on down. And we get 9 times 1, and 9 times 1 is just going to equal 9. Okay? All right, number 7. So again, you can approximate this if you want. You'll have to multiply by powers of e. But you really should have a calculator at this point, and it's what's going to help you out with some of these calculations. So ln of 43 is equal to 3.76120. So I wrote out more decimals than I need. Remember, I need to round to the nearest thousandth. So I'm going to go right here. And I want to chop off right here, but I need to determine if my 1 goes up or down. Well, it has a 2 next to it, so it's just going to stay the same. So I will get rid of the rest of them, and then just keep the 1. Okay? Last question. All right, so evaluate ln of 5.5. So you really need your calculator at this point. So you can type that in and get 5.5, and the calculator does the work for you, but don't screw up the rounding. So we get out 1.7047. So remember, our thousandth place is going to stop right here. So we're going to look at the 4 and determine whether it needs to go up or stay the same. And then it has a 7 next to it, so this 4 needs to go up by 1. So we're going to round it up to 1.705. Okay? And that is it. I hope that helped. Tutoring, of course, is available to you if you need it. Email me, whatever you need. We're here to support you. Have a great night.